Welcome to the Certificate in Renewable Energies. The star of the show is the sun. First up, we're going to take a look at how to harness the solar radiation to heat not only your water, but your home. Okay, Warren, this house is being built at the moment. They're supplementing their water heating with panels. Tell us about that.
Yes, it's designed around a diesel burner. The heating system is, and the solar panels are primarily heating the hot water, and the any extra energy will be taken through to the central hydronic floor heating.
Tell us about the cells themselves. How do they actually work? We don't want to get too scientific, but how do they actually capture that energy?
Well, it's all about the material you see here. There's actually copper pipes underneath these strips down the panels, and they're laser welded. This purple material, blue spluttered it's called, is actually laser welded to the copper pipes, and they're quite thin. And as the solar radiation heats up this purple material, and it actually collects into these pipes, and it all just is pumped through. It's a pumped system with antifreeze in it, and that water is then pumped through to a coil in the cylinder, and it just heats the cylinder through natural convection inside the cylinder.
So this house actually has underfloor heating and that sort of thing. This is what this power's going to.
Yeah, that's right. The water is heat exchanged through the cylinder. The cylinder has multiple coils in it, so that the potable water doesn't touch the central heating water, but through coils and which are inside the cylinder, they actually heat each other in a sense. Yeah.
And can you rely on it? How much sun do you need to actually help out your situation?
It really depends on how big your house is, how well insulated it is. You need to actually heat your house. We're building a house at the moment in Dunedin, and we're going to use the entire roof surface and 8 of these panels on the ground to attempt to entirely heat the house on solar. We're backing it up with a air-to-water heat pump for times when there's not enough solar gain, that can run on night rate for very cheap, and the house should virtually be able to run with almost no energy input for the hot water and central heating. Yeah.
So you can't go completely off the grid.
We're not talking about actual electricity here. It's all hydronic water using to heat the house and the hot water. Photoelectricity, electricity generation is a whole different ballpark. It can be done, and we do it, but this is not in this instance, and not in this other situation. In terms of solar, it's just heating water, which heats your house or your hot water.
And so your clients, are a lot of them building new houses, or are they actually retrofitting older houses? And can you do that?
Well, the majority actually are new customers. A lot of farmers, especially in Southland and Otago, who are actually building their dream house on the farm after they're semi-retired, and even new couples and things. Young families are doing it now, and almost every new house has some sort of solar water heating or central heating in it. So New Zealand is way behind, really, in terms of heating and alternative energy and stuff like that. But people are slowly catching up now, and they're starting to do it. Yeah, so that's mostly farmers for us, but yeah, we are really starting to get into the young families and
right. And so, how many panels? This is 2 panels. What sort of rough percentage do you think? And is there of their power bill will they be saving? And is there enough sun here in Southland for them?
Oh, most certainly. Southland and Invercargill in particular has more solar gain than Germany, where these particular panels are designed and built for that situation. Apparently about 30% more. And a 2-panel system should do 75% over the year of a five-person family. So yeah.
So well worth looking into, an interesting technology. And as you said, it was supplemented by a diesel burner,
Yeah.
which isn't renewable resources, but it's pretty special. Tell us about that. How does it work more efficiently?
The diesel burner itself, it actually uses 35% less diesel than a conventional diesel burner, and possibly more than that. We'd just like to be conservative with our estimates, simply by taking more energy out of the exhaust fumes. And the way it does it, it actually results in less carbon output through better diesel burning, atomization and such things. And it condenses because the cold water coming back hits the hot exhaust gases, which produces condensate. That's why it's called a condensating burner. And then that results in low flue temperatures, and therefore they're about 98% efficient, whereas your standard burner is around about 80%. Yeah.
Now, there's a big control panel there inside. Explain how that works. How actually is that system operated?
To put it simply, the system basically is fed from the diesel burner itself. Water flows from the floor. The cold water, or the lukewarm water coming back from the floor slab, goes to the burner, gets heated inside the burner, and then goes back to the hydronic floor heating panel as a flow and return, and then it's fed into the floor, and then it comes back. This system itself runs through the hot water cylinder, so the hot water goes into the cylinder, and it takes any
So
energy.
that's the first stop there, the cylinder.
Yeah, the cylinder's first, and then it takes energy out of the cylinder. This is where the solar can supplement the floor to a small percentage of your energy usage, and the more sun you get, the better supplement it's going to be, and it just takes any extra energy out of the cylinder itself, and it gets fed back into the floor.
Now, what about long term? What about maintenance? Is there ongoing maintenance, or are these panels you just basically set them and forget them? How about hailstones and that sort of thing? What sort of problems can you encounter like that?
There's very little maintenance with the solar panels themselves, apart from probably an annual, give them a bit of a clean down. I mean, they get film on them and it just reduces the output. So as long as you keep them clean. The water inside them, the antifreeze needs to be checked, because if it does break down over time. It's food grade antifreeze, and it just needs to be checked probably on an annual basis. We usually tie it in with the floor heating system. We have to check the corrosion protection in the floor heating systems as well. So there's always some sort of maintenance with these systems, hydronic systems. Yeah, so it's very little.
It's still well worth it, given if you were
Definitely,
pulling
yeah.
that power off the grid.
Yeah, that's right. The cost of it is actually quite low, maintaining the system. Yeah, it is very low. And in terms of hailstones, the panels can withstand quite a battering from a hailstorm. And certainly be very unlikely to get a hailstorm which could break these panels. Like hardened glass they use in them can take a hailstone of about golf ball size from 50 metres directly onto it.
Right.
Most hailstones are going to be hitting it on an angle anyway, so that adds to the actual it lessens the impact in a way.
Now, we were talking off camera about another method which would be vulnerable to hailstones, of course, some sort of thermal tubing.
The evacuated tube systems, they are a lot more fragile in the flat plate collector than we use, and they have had a lot of situations where you'd hit them with a cricket ball and they'd smash because they're very fragile things, and you have to replace the tubes in a good hailstorm. Yeah, I think you'd you'd have a lot of houses if we had a really good one.
So you recommend these panels?
Yeah, we do overall. They're a much better system. We only supply the flat plate systems.
And they're obviously changing all the time. Have you found that the length of time you've been in the industry that there's constantly technological breakthroughs?
Well, generally not with solar water heating. They with the evacuated tubes, they seem to just be fixing the problems they have with them. But with the flat plate, they're a lot more basic. So there's a lot less to go wrong, and the only technology improvements could be the material which actually captures the actual sun. It still has to transfer to a copper tube, so not so much advances with that. The technology that's there is good enough, and as a cost basis, it costs a lot to actually research these sort of things, and then it would bump the price of it up anyway. So, and then it wouldn't be viable to produce them, I suppose. But these systems are ample for producing hot water in a normal family situation. Yeah.
Well, Warren, thanks very much for your time today. I'm more enlightened to say than I was before. Thank you. Next up, we're finding out what the Southland District Council's doing to make Stewart Island even more environmentally friendly through the use of solar energy. Now, Peter, tell us about Stewart Island currently. How is it powered?
Stewart Island is currently powered by 4 diesel generators on the island, which consume many thousands of litres of diesel a year for the power requirements on the island.
And people pay, of course, for that power quite a bit.
They certainly do. In fact, Siesa has one of the highest charges for electricity in the company and the country.
Now, what is the plans for Stewart Island?
The plan is to move to a renewable energy source, and we're hoping to move to a 50% reduction in the diesel that we burn. That will be phase 1 of the project, and phase 2 will be to look at alternative sources we can use for energy production.
What is the problem with diesel?
Well, aside from the expense, which is ever increasing, we also believe we have an obligation to the environment. And of course, as you can imagine, burning diesel produces a lot of noxious byproducts that really do nothing for New Zealand's clean and green image.
So Southland District Council is obviously wanting to convert mainly to solar?
Solar and wind. There are a number of alternative energies we're investigating, but at this time it looks like solar and wind will be the predominant sources of supply for us.
Now, for the layman at home, not too complicated, how does solar work? Well, I see a panel and I see a plug in the wall. What actually happens in between?
Sure. Well, without getting into the science too much, it's suffice to say that a solar panel simply converts the solar radiation to electricity. And I think one of the important points to note here is that even on a day like today, cloudy, slightly overcast, we can still generate electricity because we require solar radiation as opposed to sunlight directly. So that seems to be a trap most people fall into.
So once you've converted the sun's energy into energy that we can use, how's it stored?
It's actually not to be stored at all. The idea at the moment is to use grid tie inverters, which allows the electricity produced by the solar panel to be fed directly back into the grid for immediate use.
For Stewart Island?
For Stewart Island.
And how? Where are you going to do? I mean, imagine there'll be a few panels involved here. Where are you actually going to put them?
We're looking at approximately 100 kilowatt of solar panels for the first stage of the project, and these will be placed on north-facing roofs within the Oban Township on Stewart Island.
And what sort of energy do you see coming out of these panels? It will vary obviously with the sun's radiation.
I think a good way to answer that question might be in terms of dollar value. We expect over the lifetime of the panels to save approximately $5.5 million in money that we would have otherwise spent on diesel to produce the same amount of electricity.
So you've obviously got to have the cooperation of the locals. How have they been? Are they happy to have these panels on their roofs?
Look, I think anything that lowers the cost of electricity for the island, has been met with a lot of optimism and support. We've had an excellent response to the residential energy survey that we did. It's approaching 55% at this time, and of that 55%, 70% of people said they would be happy to have a wind turbine in their backyard, for example. So,
now, when my first recollection of solar energy was in fact at the swimming pool in the 70s with PVC pipe all over the roof, black PVC pipe, things have obviously moved on.
They certainly have. There's new technologies that we're taking advantage of, and in fact, this particular project will be broadened to also involve offering residents of the island opportunities to further insulate their homes in order to become more efficient and use the power more efficiently.
And how would you go about doing that?
We, through Right House Meridian, it looks as though we will be able to supply the equipment required at a cheaper retail rate than would otherwise be possible.
So subsidising the client?
Subsidise, exactly right. And furthermore, we have ECA, which is the Energy Efficiency Conservation Authority, now indicating that they would be willing to use some of their money to help with people on incomes inside their criteria for support.
Has the government come on board? Have they said to the Southern District Council that we want you to get more energy-wise and that sort of thing, or is it a local initiative?
That's a really good question. The government has said on a number of different occasions that the idea of Stewart Island burning diesel for energy is ridiculous, but never offered any direct support in terms of finances. And so at this time, the only support we've had from the government is by way of ECA, who've really come on board to help push this thing through.
So as far as any sort of environmental impact, how do you expect there to be an environmental impact of this conversion, except minimising the carbon?
I guess what I would like to see is that if we can offer electricity at a cheaper rate, it might induce people to burn less coal and diesel for heating and that sort of thing. And looking perhaps slightly into the wider picture, that we might attract eco-tourists and people interested in conservation as a whole to the island if it's running on a completely renewable power supply.
Does this scheme also involve education of the public and to conserve? I mean, we all should switch off these appliances that we leave on overnight and that sort of thing. Is that another part of it?
And as part of the efficiency project, we'll be certainly producing, education documents and perhaps even run seminars for residents on the island on how they can be more efficient.
Also, you said that you want to have the island on either solar or alternative energy. What are those alternatives and how affordable are they?
Well, at this time we don't have the exact costing for the project. We have a report due by the end of the week that will have the final costings on, for the project. At this time we're looking predominantly at solar and wind. There are opportunities on the island for some micro hydro projects and also the potential for a tidal or wave power generation unit.
Yes, I was about to mention that. We all hear these things and we've of course got enough tide around here to power it. How far away is that sort of technology?
The technology exists and it's in use overseas, but the difficulty of course is you need fairly accurate data about your water movement before you can decide what type of marine supply is suitable for your environment. So,
now, what made the council decide to initially start with solar?
Well, the sun's always shining, but we moved to a renewable energy supply because if you look at the rising costs of fuel and diesel, the price of electricity on the island is already unsustainable for most people, and it's only likely to climb if we continue our reliance on diesel. So therefore an alternative supply was investigated. We looked at running a cable between the mainland and Stewart Island, and that costed in at about $8.5 to $9 million. So it seemed that we needed a local generation supply of some sort.
Was biodiesel considered, or would the generators simply be of an age where they couldn't deal with it?
Not at all. In fact, biodiesel is still considered an option. And in fact, if we move to a 50% renewable supply through solar and wind and hydro, we may look at providing another 50% through biodiesel or possibly through hydrogen, depending on what we decide to do finally.
Now, as these panels go on, how big are these panels? Are they going to take up the whole roof and that sort of thing, or are they, quite small these days?
They come in all sorts of shapes and sizes, and the roof space covered will depend really on the angle of the roof and the direction that it faces.
Are there people currently on the island employing these sorts of methods for heating water or whatever?
There are certainly people using solar hot water systems on the island, and we hope to go down that path also. In fact, we're installing a demonstration unit towards the end of this month.
Now, this initiative, does it only apply to Stewart Island, or are there other areas in Southland District that perhaps could benefit, where you wouldn't have to run a cable and you can use solar?
Look, by all means, there's absolutely no reason why small communities can't perhaps look at this sort of system. I guess Stewart Island is special in as far as it's not connected to the national grid, and the power supply company for the island is run by council, whereas that perhaps doesn't exist throughout Southland as a whole.
Well, Peter, thanks for your time today, and how long do you think this project will take? You say by the end of the year?
I would hope by the end of the year that we're well underway. We should be pretty close to the conclusion of phase 1.
Thanks for your time.
Thank you.
Coming up, we find out how you could use the floor in your home to store the sun's energy. Now, Gareth, this is a very interesting house, isn't it? Let's start firstly by the positioning of the house originally, when it was designed, and how it can best benefit from the sun.
Okay, yeah, the house has been deliberately orientated. It's a long house and deliberately orientated to the north. And then it's been built with the roof pitching up into the north so that you're getting a lot of glass frontage and a lot of solar gain, particularly during winter months to pull in. So it's been deliberately orientated that way.
Just looking at the construction of this building, the framing, these don't look like normal 4x2s.
Yes, it is. The walls on this house are 150 millimetres thick, the extra 6 inch, the old 6 inch in the old style. That's to carry extra insulation. And in addition to that, there will also be 60 millimetres of polystyrene going on the outside of the wall, which again, more insulation again before the brick veneer. So the house is also going to have double glazed windows with argon gas. They're low E windows, so the energy losses from those are going to be is reduced as much as possible.
How does the argon gas work? Is that actually injected in between the...
That's between the sheets of glass, and just enabling that, not just a vacuum, but actually giving an extra barrier to heat loss.
So what you're saying is the house itself is actually a perfect collector of solar energy?
Well, yes, in itself it's designed to collect extra solar energy, but it's also designed to retain as much of that as possible within traditional building methods without going to heavy concrete walls and things that can actually also collect a lot of heat in the summer when you don't want them to deliver to the house. So it's a bit of a compromise between those two systems.
So how much concrete is there actually in this house? I mean, the floor's obviously concrete, but any walls?
No, there'll be no primary walls that are concrete. That's primarily being put into the floor. The slab's an extra thickness as well. It's 150 millimetres as well. And then underlying that is 70 millimetres of polystyrene to insulate it from the ground.
Now let's move on to the actual panels and that sort of thing that are going to be employed on this house. Firstly, how is the house going to be heated besides just natural sunlight?
The main heating of the house is through the floor, a heated floor system, hydronic floor system, and it's going to be powered primarily by a solar system, an array of panels which collect the water. They run that down through the hot water cylinder and then through a control panel. Then the first priority for that heated water, which is actually a transfer fluid because it carries glycol for frost protection, the first priority is to the heating the floor. And when it's attained that temperature, any excess heat generated by the system is then put through to storage areas underneath the house. They're 10 cubic metre concrete storage areas with layers of pipe. They can store the excess energy and then the system can draw it back when it needs it later on.
How popular is this sort of work? Is your company actually carrying out this sort of work, or is it quite groundbreaking?
It's a bit of a mix. There's a lot of interest in this kind of thing. There wouldn't be a lot of people that have actually done it. And it's now coming into that zone where it's economically viable to seriously consider doing this kind of concept.
Now behind us here we've got this array of pipes coming out of the floor. Please explain in layman's terms, if you could, a layperson's terms, how it works.
Okay, the pipes coming out of the floor here, there's normally not so many in a standard heated house because they're just going into each zone of the house. Each room is heated in a zone, and these pipes are the pipes that feed out to those rooms. This one's got a few more because they're also bringing pipes back in from the storage areas. So we're bringing water back to the system as well so that it can be dissipated through the house. So that's primarily, those pipes are just all through the floor and they're just feeding back up, and the control panels deciding where to put that heat depending on the demand from the thermostats.
Now the storage area you speak of, it is like a battery, isn't it, without having to have a battery?
Well, yeah, that's exactly what it is. As I say, there's two 10 cubic metre blocks of concrete. They've got 3 layers of pipes in there, and the hot water or the warm water goes into those areas where it's that whole area is insulated with polystyrene, so they're completely self-contained units. They're under the house, but they don't heat the floor, but they store the heat, and then it can be pulled back from there to deliver to the house.
Now it's not a fantastic day today, but you still would be gathering some sort of energy out of the sun today?
Yeah, if you use the right panels, there are different kinds of systems, and the panels we're using on this house are particularly suited to coastal conditions because they pick up radiation from 2 sources, both from direct sunlight, but also from diffuse radiation, which bounces around underneath the clouds on a day like this. They're particularly good at doing that. There are other panels that are more efficient in direct sunlight, but in this situation, these black chrome panels will have an advantage.
Did your client consider using the vacuum tubing that is also on offer?
This client probably wouldn't have seriously considered that because there's several disadvantages to those systems, particularly in the domestic hot water situation. So in this situation, with the flat panel system being more efficient to the 80 degree C water mark, it's a much better option and cheaper option for doing this kind of system.
Now, long term, I guess people are sitting at home going, yes, this is all very well, but how much is the cost, the added cost when building? You're talking a lot of extra resources into the flooring and that sort of thing, aren't you?
There will be some extra costs. The full cost hasn't been totally quantified because it's a little bit of an experimental project, but also got to remember that some of those costs can be recovered because, such as the storage area, that area had to be excavated anyway and filled with something. What we've done is chosen to perhaps fill it with something perhaps a little bit more expensive than conventional, but some of those costs can be ridden out with that. Long term, you're going to be saving an enormous amount of money on your energy bill. And with energy going up at sort of 12% per annum, it's not going to be long before your power bills are minuscule compared to a house of the same era without a system like this.
Now, I've learned a lot in the very short time we've been talking. You're finding a lot of people are coming around that when they are building a house, they will actually seriously consider these options?
Yeah, they are. Primarily, they've been considering just the heating of the floor and using the most efficient system possible. But it's becoming increasingly important to look at the whole house as a package of heating. In terms of solar radiation capture for the house itself, water systems, heating systems, to get more energy efficient. So people are becoming smarter about it. They're thinking more about it, and I think they're considering the longer term, implications financially of it.
How maintenance intensive are they? Is there much you really have to do with these systems, or are they set and forget for 15 years?
In terms of the solar, you're probably going to get 15 to 25 years without ever having to look at it. It will be running itself, the quality components. The floor systems are also, their expected life is over 100 years. They've got 25-year guarantees. Apart from, some systems require a little bit of maintenance every couple of years just to check the water and balance the water up, that sort of thing. But really, it's a no-touch system for the owner.
In those really hot days when perhaps there's been a bit too much solar activity, how do you actually dissipate that heat and energy?
Yeah, sure. That's a big thing that people often think, I want to heat my floor with a solar system. The trouble is that in the summer it's going to be overkill. You're going to have way more energy than the house needs, and you need somewhere to dissipate that heat. In this house, it's going to be dissipated through the garage floor in the summertime, but other people could choose to dissipate it through a swimming pool, for instance, that kind of thing. So yeah, it can be a problem.
Well, this particular client is your boss, so I hope everything goes well with the house.
Yeah, so do I. That would be a great thing. That would be good for both him and I.
Well, thanks for your time today.
That's my pleasure.
Well, thanks for watching the Certificate in Renewable Energy. If this course or any other for that matter appeals to you, then please phone 0800 SIT to learn. We look forward to catching up with you next time. Well, thanks for watching this edition. You could use the floor in your home to store the sun's solar radiation energy. Do it again.